Okay, so we are solving more polynomial equations, and it will sometimes involve sum or a difference of cubes. So let's go ahead and do a problem here. Solve, and we've got 16x to the fifth minus 250x squared equals 0. Okay, so look for factoring. Factoring is most likely going to be happening here. For example, I noticed there is a GCF of 2 and x squared. So 2x squared GCF, and that would leave me 8x to the third minus 125 equals 0. Okay, now the 8x cubed minus 125, I recognize that as difference of cubes because we have 2x quantity cubed minus 5 quantity cubed. Remember, SOAP, same, opposite, always positive. So we've got the same minus opposite and always positive. Okay, don't forget sum and difference of cubes formula. If we have a cubed plus b cubed, SOAP, as I was already mentioning, a plus b, same sign, opposite, and always positive. A squared, b squared, and ab right there. And if it's difference of cubes, then just remember the SOAP and same, opposite, always positive, and you've got two formulas for the price of one there. Okay, so here's the A and the B. So 2x and 5, and this is a squared, so square the A. So 4x squared, here's b squared, so square the b, 25, and this is a times b, so a and b, so that would be 10x. Now, don't forget about the GCF. GCF needs to come along for the ride here, and here's equals 0. So now using the zero product property, we've got 2x squared equals 0, we have 2x minus 5 equals 0, and we have 4x squared plus 10x plus 25 equals 0. Of course, if 2x squared equals 0, hopefully that's fairly obvious that x equals 0. And 2x minus 5 equals 0, hopefully that's fairly obvious that x is 5 halves. Add 5, divide by 2. Now, 4x squared plus 10x plus 25 might look like it factors, but if you are following the hierarchy for factoring, you check for GCF first, then you check for difference of squares, and then you check for sum or difference of cubes, the right-hand side will not factor over the reals if you follow that factoring hierarchy. So we have a choice, since it doesn't factor the way we would normally think of factoring, of either completing the square, solving by completing the square, or using the quadratic formula. Now, looking at the terms here, there's not a 1 in front of the squared term, so probably I would just go ahead and do quadratic formula. Let's not forget the quadratic formula. If ax squared plus bx plus c equals 0, if you can get it in that form, which we are, then x is equal to opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, now, at some point in this unit, we're going to see how the quadratic formula came about. Maybe today, but I don't know. These notes are not short already anyway. Might be the block day when we do that. So I would suggest let's just go ahead and do the quadratic formula. A is 4, B is 10, C is 25. So x equals opposite of the B plus or minus square root, square the B, so 10 squared, 100, minus 4 times the A times the C all over 2 times the A. Okay, now you have to clean it up. As you're cleaning it up, what you will notice when you're doing this anytime with the sum or difference of cubes, you're always going to get imaginary. So negative 10 plus or minus, we have square root of 100 minus 400, so over 8. And so that's negative 10 plus and minus the square root of negative 300. So now you can see we are getting imaginary. And the 300 would be 10 root 3. So this is negative 10 plus and minus 10I root 3 over 8. Okay, now, even number, even number, even number. So there's a GCF of at least 2. It's only a GCF of 2 because 10 is 2 times 5. So this reduces to negative 5 plus and minus 5I root 3 all over 4. So there's a GCF of 2 that gets reduced out of all those terms. Okay, so our solution set, we've got 0, we've got 5 halves, and we've got these two solutions, negative 5 plus and minus 5I root 3 all over 4. Okay, and so all those solutions. Now, anytime you are using the sum or difference of cubes, you're always going to have a pair of imaginary solutions in there. On the other hand, if you're doing sum or difference of cubes, doesn't it seem reasonable that we're always going to have a real root as well? Because the A plus B, you'll be getting a real root coming out of there, whereas you'll be getting two imaginary roots coming out of the A squared minus AB plus B squared. That right-hand side, that's where you'll get the imaginaries. Okay? Okay, so there was a bit more to the lesson based on the title. We have solutions with functions, and so these are just kind of some functions in general. So here's a couple functions. We have y equals f of x, which is almost kind of a W shape. It's intersecting the x-axis a few times. And we also have y equals g of x, which appears to be linear, and they're intersecting each other. It also intersects the x and y axis some places. And it's got lots and lots of points here. So if you need to stop the video and just take time to sketch this, go ahead and sketch this right now. Label all the points as you see it. Okay, once you've got that sketched and labeled, then we're going to be asking you some questions here. So it says identify all points, but really it's identify all labeled points. So identify all points that satisfy where f of x equals g of x. Well, let's think about that for a minute. Where would f of x equal g of x? Well, wherever they have a common meeting point, and they have common meeting points at points of intersection. Okay, so points of intersection then. So which points of intersection are labeled? Well, B is, and F, and I, and K. Okay, let's do points, labeled points, that is. Points on f of x where f of x is greater than g of x. Okay, well, where is f of x greater than g of x? Where is f of x above g of x? So f of x, that's the W-shaped one. Where is it above g of x? Well, for example, right here in the middle between points f and I, f is above g of x. But are there any points on f in between f and I where f is above g of x? Well, sure. Okay, so the point G satisfies that. Okay, is there any other place where f is above g of x? Well, yeah, out here far to the left, f of x will be above, but is there a labeled point on f of x where it's above g of x? No, because it's the point of intersection, but it's not above there, so there aren't any label points out here. How about over here to the right? F is above g of x. Are there any labeled points out there? Yes, M. So points on F where F is above, greater than, above g of x. So point G and point M. Now we can go the other way with that as well. I mean, we could do, you know, points on G, where that's, oh, I left off one too, didn't I? How about point L? Oop, I almost forgot that. And point L. Sorry, L and M are both above. Okay, moving on now. Points on F, points on f of x where, let's do the other way, g of x is greater than f of x. Okay, again, they have to be points on f where g is above f. Well, first off, where is g above f? G is above f in this section between b and f. Are there any points on f where g of x is above f of x? Yeah, there's C, D, and E are all points on f where it's above, where g of x is above. Okay, so C, D, and E. Is there any other place where g of x is above f of x? Well, g of x is above f of x here between I and K. Are there any points on f of x where that is true? Yes, point J and J. Okay, so 4 points there. There are more points than this. It's just these are the only labeled points where this is true. How about points on g of x? We haven't done any where it's points on g of x, where f of x is greater than g of x. Okay, so first off, where is f of x above g of x? F is above g of x out here. Do we have any points on G where f is above G? Yes, point A. Any other place where f is above g of x? Yes, here in the middle between f and I. Are there any points on G where f is above g of x? So yes, H. And any other place where f is above g of x. Yes, out here to the right, f is above g of x. Are there any points on g of x where that's happening? Yes, at n. So a, h, and n. Okay, and obviously we can go the other way as well. We can do points on g of x where g of x is greater than f of x. Okay, these are always the labeled points. So are there any points where g of x, first off, where is g of x above f? G of x is above f here, between b and f. Are there any points on g of x in that section? No. Any other place where g of x is above f of x? Yes, between I and k. Are there any points on g of x between I and k? No. Those are the only two places where g of x is greater than f of x, and there just aren't any labeled points on g of x where that is true. So none. We can also do some things sort of like this. Points on f of x where f of x is less than 0. Okay, well, what does it mean by less than 0? Well, it means where f is negative, right? So is there any place where f is negative? First off, well, it's negative anywhere it's below the x-axis. So are there any points on f where it's below the x-axis here? Well, sure, at D. So got at least D. Any others? Well, yeah, over here we're below the x-axis. Any points on f where f of x is less than 0? About J and K. Okay. And so they can always do less than 0, greater than 0, stuff like that as well. How about, I think I'm running out of space down here at the bottom. Let's move it up some. FG. Move it up here some. How about the point where we have g of 0? Well, that means we're inputting a 0 for the x. Where is x equal to 0? Isn't that always on the y-axis? So we're doing g of 0. So the function g, where is g of 0? Isn't that at h? Yeah, because if we're inputting 0 into a function, we're looking for the y-intercept. So the y-intercept of g would be at h. We can also do things like, let's see, h here. Points on, let's do f of x, where f of x equals 0. Okay, we're not doing f of 0, I'm doing f of x equals 0. So now remember, f of x is another way of writing y. So y equals, well, where is y equal to 0? Well, y is equal to 0 on the x-axis, isn't it? And we want points on f of x where f of x equals 0. So does f have any x-intercepts? Because that's what we're looking for. C, E, I, L. C, E, I, and L. Okay, last problem, multiple parts to it, but Given a table of values for two continuous functions, remember continuous functions, we do not lift our pen or pencil from the paper as we're sketching the function. Two continuous functions, f of x and g of x, answer the following. So here are the two continuous functions. At least we're taking snapshot views of them. So at x equals 0, we know what the y value is for f. We know what the y value is for g. And so on, at 1, at 2, at 3, at 4, all the way up until 7. These are just snapshot pictures. Okay, so A, identify the open intervals where g of x equals 0 must occur. Okay, so not maybe, but must. Okay, there's going to be a number line there. And if we do a number line and we want all these different points, 0, 1, 2, 3, all the way through there. So 0, 1, 2, 3, 4, 5, 6, and I need a little bit more, 7. Okay. So we're going to check out the function g along the way. Now realize g of x equals 0, isn't that the x-axis? Elevation 0, x-axis, y equals 0. So let's take a look at g. So my function g at x equals 0, it's at elevation -4. So isn't that below the x-axis at x equals 0? And then it's at -1 at x equals 1, so it's still below the x-axis. At x equals 2, it's at elevation 3, so all of a sudden it's above. So by the way, if it's below here at x equals 1, and if it's above here at x equals 2, and it's a continuous function because they promised us that, what must have happened at least one time between 1 and 2? It must have crossed the x-axis somewhere there. It crossed elevation 0. So somewhere in there, it crossed. Okay, moving on. At 3, we're at elevation 8. I'm above. Did it cross? Maybe, but there's no evidence showing us that it had to have crossed. At 4, we're back at -2. I didn't mean to write -2. It's more important that we actually do it's below. Okay, it's below. Now, since I'm above here and I'm below there, didn't we have to cross the x-axis somewhere between 3 and 4? Okay, so a little down arrow to keep track of the fact that it's below right there. Okay, at 5, we're at elevation 1. It's above, so guess what? It had to have crossed again somewhere between 4 and 5. And then at 6, it's at 6, which is above. And then at 7, we're at -3, which is below. So again, it had to have crossed somewhere between 6 and 7. Okay, so this is number lines, kind of messy. Let's write it out in interval notation, what we have going on. So we've got 1 to 2, union 3 to 4, union 4 to 5, union 6 to 7. Those are the ones where it had to have crossed somewhere in those intervals. We could also do something like this. Identify open intervals where f of x equals g of x must occur. Okay, we're only going for the ones where it had to have happened. Okay, now, again, number line situation. Okay, and 0, 1, 2, 3, 4, 5, 6, 7. Okay, now we're trying to see where they're equal to each other, so I want to see where one's below the other one. So we're going to compare. I want to compare either F versus G or G versus F. So whichever way we're going to do it, just figure out which. I'm going to say F versus G. F versus G. So I'm going to compare, is F above or below G? If you do G versus F, you're checking to see if G is above or below F. So I'm doing F versus G. So at x equals 0, is F above or below G? Well, -3 is above -4, so F is above at that point. How about at 1? F is above because 2 is above -1. How about at 2? F is above because 5 is above 3. How about at 3? Oh, F is below because 7 is below 8. So somewhere between 2 and 3, since they're both continuous functions, they intersected each other. Let's check at 4. At 4, F is above. Guess what? It was below here. It's above there. Somewhere between 3 and 4, they intersected. At 5, we are above. At 6, we are above. At 7, I am below. F is below G of x. Negative 8 is below -3. Okay, so somewhere between 6 and 7, they intersected. Okay, so there it is on the number line. If we're doing interval notation, we got 2 to 3, union 3 to 4, union 6 to 7. Okay, so we don't want to spend a lot of time with this, but you do want to be accurate, and it's pretty easy to be accurate too. Last one, and then we're done with the notes. Okay, identify open intervals where f of x equals f of x equals let's do 6 must occur. Okay. Well, this is almost like doing g of x equals 0. You're just checking to see if it's above 0 or below 0. So f of x equals 6. You know, it's like you're doing the number line thing, and 0, 1, 2, 3, 4, 5, 6, 7. And you're just looking at the function f, and you're comparing it to elevation 6, f versus elevation 6. And so is f above or below 6? Well, you know, it's below, it's below, it's below, it's above, so somewhere between 2 and 3. It's below, so somewhere between 3 and 4. It's below, oh, nope, sorry, at 6 it's above. Sorry, at 6 it's above elevation 6. So somewhere between 5 and 6, and then it's below here, so somewhere between 6 and, so very similar. Now, will there always be solutions? No, there won't always be solutions. What if they did something like, and I'm almost out of space, so I'm going to do it right here next to the box. How about where g of x equals, let's do 9 must occur. Okay, g of x equals 9 must occur. Well, g of x, if you do the number line, it's below 9, it's below 9, it's below, it's below, it's below, 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 below. Is there any place where it has to occur? No. G of x, there's no evidence showing g of x equals 9 must occur. Now, on the other hand, could there be a solution somewhere? There could be, but we have no evidence showing it because all the snapshot pictures we have, the values of g of x are always below 9. And the lights just went out. Must be time for me to go home. Good night.